We're going to learn about solving systems of equations. A system of n linear equations and m variables is a collection of n equations using m different variables that must be solved simultaneously. Okay? Meaning that a solution to such a system is a collection of m numbers that when you plug them into each of the variables, every single one of the equations will work out. Okay? Graphically, a solution is where the graphs of each of the individual equations intersect each other. So, let's do some examples. This is a system of 3 equations and 3 variables, and we want to see whether either of these 2 points are a solution. So to test if a point is a solution, I'm going to plug x equals 2, y equals 1, and z equals -3 into each of these. To be a solution, it must satisfy all 3 equations. So as soon as we get that it doesn't satisfy an equation, we immediately know that it is not a solution to the system. So I'm going to plug it into the first equation, and I'm hoping I'm going to get -3. This is 4 minus 1 minus 12, okay, or 4 minus 13, -9, which does not in fact equal -3. So this first point is not a solution to the system. Let's try the second point. I'm going to plug it into the first equation. And I get 6 minus 7, which is -1, minus 2, that does equal -3. But I still don't know it's a solution to the system because I haven't checked the other 2 equations. I get 3 minus 14, which is -11, plus 5, which is -6. But I still don't know it's a solution until I check the last equation. I get 9 minus 2 does in fact equal 7. So this point is a solution to our system. Now, how do we find the solutions to the systems? Well, we're going to learn 3 different methods. And the first one is by graphing. So we're going to start with a little bit of a simpler system, 2 equations and 2 variables, because we can't graph anything with more than 2 variables. First of all, to be able to graph these, I need them in y equals mx plus b form. Okay, so I'm going to do a little bit of work and solve each of these for y so that I know how to graph them. Okay. Now, okay, the bottom one has a y-intercept of -2.5 and a slope of 3/2. So this is that equation. The top one is y equals -x. It's that equation. So it looks like they intersect here. Now, the reason this is not always the best method to solve these is because sometimes it's a little bit hard to make sure you actually get the right point from a graph because some of us aren't very good at graphing precisely. So you always want to check this, get the points in the end, and make sure that it actually is a solution to the system.